So let's start with, okay, before we proceed to a formal analysis of regression theory, let us dwell briefly on the matter of terminology and notation. In the literature, the terms dependent variable and explanatory variable are described variously. A representative list is the next one. Okay, so for dependent variable we have another terms that are the same is explained variable, predictant, regressant, response, endogenous, outcome, and controlled variable. For the explanatory variable we have independent variable, predictor, regressor, stimulus, exogenous, covariate, and controlled variable. Okay, if we are studying the dependence of a variable on only a single explanatory variable, such as that of consumption expenditure and real income, such a study is known as simple. Okay, or two variable regression analysis. However, if we are studying the dependence of one variable on more than one explanatory variable, as in the crop yield, rainfall, temperature, sunshine, and fertilizer example, it is known as multiple regression analysis. The term random is a synonym of the term stochastic. As noted early, the random or stochastic variable is a variable that can take on any set of values, positive or negative, with a given probability. Okay, let's go see the different type data. Okay, the three types of data may be available for empirical analysis. We have the time series, the cross section, and the pool data. For the pool, for example, we have the combination of time series and cross section data. Okay, the first is the time series data. The data shown in the table 1.1 are an example of time series data. This is the time series data. So let's go see how looks this one. Is here. Yeah. So this is our the table 1.1, and this data is time series data. Okay. The time series is a set of observation on the values that a variable takes in different times. Okay, so we have time 1 and type 2 for the, what is this, the expenditure? Let me check the X production. Yes, it's the X production in time 1 and the X production time 2. More specifically, is the X produced in 1990 and the X produced in 1991. Okay, those data may be collected at regular time intervals, such as daily, for example, stock prices, weather reports, weekly, for example, money supply figures, monthly, for example, the unemployment rate, the consumer price index, CPI, or quarterly, for example, the GDP, um, annually, for example, the government budgets, quinquennially, that is every 5 years, for example, the sense of manufacture, or decennially, that is every 10 years, for example, the census of population. Sometimes data are available both quarterly as well as annually, as in the case of the data of GDP and consumer expenditure in United States. With the advent of the high-speed computers, data now can be collected over an extremely short interval of times, such as data of stock prices, which can be obtained literally continuously, the so-called real-time quote. Although time series data are used heavily in econometric studies, they present special problems for econometricians, as well as we show in the next one's videos on time series econometrics later on. Most empirical work based on time series data assumes that the underlying time series is stationary. Okay, Although it is too early to introduce a precise technical meaning of stationarity at this juncture, loosely speaking, I'm saying that a time series is stationary if its mean and variance do not vary systematically over time. Then that's time series data. And the next one is cross-section data. Cross-section data are data on one or more variable collected at the same time at the same point in time, such as the census of population conducted by the Census of Bureau every 10 years, the surveys of consumer expenditure conducted by the University of Michigan, and of course the opinion polls for Gallup and 18 other organizations. A concrete example of cross-sectional data given in the table 1.1, okay? Again, our table. This table gives data for eggs production and eggs prices for 50 states in the union of 1990. This is the Y1 and X1 and 1991, so Y2 and X2. For each year, the data of the 50 states are cross-sectional data. Thus the table 1.1, we have two cross-sectional data samples. Just as time series data create their own special problems, uh, well, I'm sorry, cross-sectional data, yes, a sectional data for this one and one sample from the price, and the other sample is for the production. Okay, just as the time series create their own special problems because the station identity issue, cross-sectional data too have own problems, specifically the problem of heterogeneity. Okay, from the data given in the table 1.1, we see that we have some states that produce huge amount of eggs, for example, from Pennsylvania, with Virginia, and some other produce very little, like Alaska. Hmm. Hey, is Alaska? Yes. California. Oh, nice. Mm, okay. And when we include such heterogeneous units in a statistical analysis, the size and the scale effect must be taken into account so as not to mix apples with oranges. Okay. Then pool data. Okay, what is pool data? In pool data or combined data are elements of both time series and cross-sectional data. And again, the table 1.1 of our eggs produced in different 2 years and their price per dozen in different 2 years, we have data that are an example of pool data. Okay, data that is example of pool data. For each year, we have 50 cross-sectional observation, and for each state, we have a two-time series of observation on prices and output of eggs, a total of 100 pooled observations. And finally, we have the panel longitudinal and micropanel data. This is a special type of pooled data in which the same cross-sectional unit, say the family or a firm, is surveyed over time. For example, the United States Department of Commerce carries out a census of housing at periodic intervals. At each periodic survey, the same household or the people living at the same address is interviewed to find out if there has been any change in the housing and financial condition of the household since the last survey. Okay, this is the end of the first lesson. I will start the next in the next video. Okay, see you later and thank you.